In this lecture, we are going to discuss the next portion, that is actually the general equation of second degree. I discussed rotation of axis. Now I need to discuss the second degree equations, okay, and classification of conic using this discriminant, this portion. But over here, as per this discussion, we need to know about these two chapters. One is the general equation of second degree, and another is a pair of straight lines. Probably you have done a bit about pair of straight lines in class 11 and 12th level, but I need to go through both of these two chapters, general equation of second degree and pair of straight lines, in order to complete the entire discussion. Got it? I need to go through both of these two chapters. So I am currently starting the chapter general equation of second degree, and as per the book, that is actually your chapter number 10. Hmm. But the pair of straight line, that is actually your chapter number 2. So I need to discuss both together so that it become clear to you. Hmm. Probably you have done a bit about pair of straight line. Is it so? তোমরা কি 11-12 কিছুটা পড়েছিলে তোমাদের পেয়ার অফ স্ট্রেট লাইনে, তোমাদের কারেন্ট সিলেবাস ওয়াইজ তোমরা যেরকম পড়ে এসেছিলে, সেটা একটু জানতে চাইছি তোমাদের কাছে। কে কি বলতে পারবে?
হ্যাঁ স্যার, পেয়ার অফ স্ট্রেট লাইন ছিল।
সেখানে কি কি ছিল? পেয়ার অফ স্ট্রেট লাইনে কি কি ছিল?
সেটা এখন মনে নাই।
মনে নেই? Anybody else? Let me start this chapter, that is actually the general equation of second degree. Why is it called general equation of second degree? Because over here we are actually dealing this kind of expression. You already got this kind of expression in the first chapter. I told you that this is actually a general second degree expression. Why general? Because it contains all the expressions of second degree up to second degree. Second degree means second degree as well as first degree as well as the constant term. So first three terms, these are actually the total second degree expressions. Along with that, we have some first degree term and a constant term. So all these three expressions together become a general expression, and as when it is equated to 0, it becomes an equation. That's why this is called general equation of second degree. Now, before starting this discussion, I need to define the curve of second order. What is called the curve of second order? Okay, and the canonical form or the normal form of those kind of curves. But before that, let me ask you one question. Do you know what is conic? কনিক কাকে বলে বলতে পারবে? বাংলায় যে কি বলে আমি ভুলে গেছি বাংলাটা। কনিক, what do you know? Have you got this term conic? CONIC? Sorry, I couldn't follow you.
Yeah, sir, it was in 12th class.
यहाँ से hello?
Yeah, sir, it was in class 12th, conic section.
Conic section is fine. I am talking about the definition of conic. What is conic? What is conic? Do you know what is conic?
Sir, I know a bit that it is a locus of some points.
Okay, fine. That's a partial answer. Good. But what kind of locus? Does it satisfy any kind of conditions?
Yeah, sir, we need some ratios of fixed points, the distance between that
And what
points.
what are these two distances?
I mean, I'm not getting your, what do you want to know?
You told me that this is actually a ratio. It satisfies certain ratio, isn't it? Hmm.
Yeah, sir.
I want to know the ratio of which two distances.
Focus and the directrix.
Okay, good. Uh, Actually, in that case, let me clear the definition. That is a good answer. Thank you. I many of us don't know the proper answer. So let me first show you the proper definition of conic. Okay, that is a good answer. Thank you for the answer. And I am trying to show this one from the website because over there I don't need to draw any picture. I will get a ready-made definition. Hmm. What is the definition of conic? Okay, fine. There, conic section and conic. Mainly, if you have any confusion regarding any definition in mathematics, most of the definitions are available in Wikipedia. You can go through all these definitions, and mostly they are very good standard definitions. Hmm. So let's directly try to go to the definition. Firstly, it appears that if we have a cone and if we consider the section of that cone by a plane, then sometimes we get a circle, sometimes we get an ellipse, sometimes we get a parabola, sometimes we get hyperbola, depending upon what kind of section do we consider. But that is a very geometric expression, but it depends upon the picture. But and mathematically, and except apart from the picture, if you want to give mathematical definition, in that case, in terms of coordinate geometry, you will have to define a definition, define it, and that is the this is the picture that would be helpful for us. Let's make it a bit larger. Is it clearly visible to you, this picture?
Yes, sir. Yes, sir.
Let me go through the full screen. Yeah, little bit better. Over here, what we have in order to define in order to define a conic, okay, what we have, we actually have a fixed straight line. Firstly, we actually have a fixed straight line and a fixed point. In order to define any conic, we always need a fixed straight line and a fixed point. Got it? And we consider a point. In your book you will find that the arbitrary point is equal to capital P, and over here they have taken the point capital M. No problem is there. And from this point we consider the uh, distance of this straight line, the perpendicular distance of this straight line, and that shortest distance from this point and this fixed point capital F. F is called focus. This particular point is called the focus, and this straight line is called the directrix. Okay, বাংলায় যেটাকে বলে নিয়ামক সম্ভবত, আমি যদি খুব একটা ভুল না বলে থাকি। হুম ফোকাসকে কি যে বলে ভুলে গেছি। হুম এনিওয়ে,
Navi.
মেবি তাই হবে হয়তো, নাভি। ওকে, so this fixed point is called focus, and this straight line, this fixed straight line is called directrix, and we consider these two these two distances, p it's not p, m f divided by m prime, this distance. And this ratio, mf divided by m prime, this ratio is denoted by the this letter e. and this constant quantity E is called the eccentricity, বাংলায় যেটাকে বলে উৎকেন্দ্রিকতা, হুম, the eccentricity of the conic. Okay, and if the particular point always satisfies the ratio that mf by mm prime is equal to a constant quantity, the constant may be different for different curves, but for a fixed curve the this value of E is a fixed value, and that particular in that case we can it is found that this m ultimately goes through a particular curve, and that in that case the locus of that curve is called the conic. Okay, for suppose over here if E is equal to 1, in that case the conic over here, it is actually the green line. Hmm. This conic is called parabola. বাংলায় বাংলায় যে কি বলে ভুলে গেছি, পরিবৃত্ত বা এরকম কিছু একটা মনে আছে, নাকি ভুলে গেছি, পরাবৃত্ত এরকম কিছু একটা নাম আছে। হুম, so when E is equal to 1, this is called parabola. When E is less than 1, okay, when E is less than 1, then the curve is called an ellipse, particularly when E is equal to 0. When E is equal to 0, we get a circle. So ellipse is actually a general version of circle, or in other word we can say that circle is a particular kind of ellipse when E is equal to 0. If E is less than 1, then the curve is called an ellipse. Okay, and in that case the curve becomes always a closed curve. আমরা এখানে সবসময় একটা closed curve পাবো, or ellipse is always a closed curve, but parabola is never a closed curve. It has actually an infinite branch in this zone, and an infinite branch on this right side as well. Okay, so parabola is not a closed curve, closed in the sense that the curve would ultimately again meet to that curve after few times or after few iterations. Okay, and if E is greater than 1, over here they have given an example where E is equal to 2. So if E is greater than 1, in that case we find that the curve has actually two different branches. এখানে একটু ভালো বোঝা যাচ্ছে নাকি, লাইনটা চলে আসছে বারবার। এখানে ইয়েটা লেখা আছে, if E is equal to 1, we get a hyperbola. Okay, if E is greater than 1, we get a hyperbola. So over here this is the second branch of the hyperbola. হুম, বাংলায় যে কি বলে ভুলে গেছি, আই এম সরি, আই কান্ট রিকল দ্য বেঙ্গলি ভার্সন। হুম, so that is about the definition of conic. Now is it clear? Do you have any question regarding the definition of conic?
No, sir.
Okay, thank you. So let me close this. So if you have any question regarding the mathematical definitions, you can go through this Wikipedia, and you can search over here whatever definition you need to know. Mostly you will find very good definition with proper explanation and proper picture over there. Okay. Now we are going to show in this chapter that a general equation of second degree, where is that? This one. A general equation of second degree always either represent a pair of straight line, or an ellipse, or a hyperbola, or a parabola. These are the possible kind of equations, all the different kind of curves that can be represented by a general equation of second degree. Okay, now in order to identify and the nature of the curve, we mostly apply different kind of orthogonal transformation. Either we apply translation or we apply rotation, because we already proved in the first chapter that this kind of transformation formula does not change the geometric figures. So we are very sure about the fact that an ellipse will always be an ellipse under this kind of transformation. Similarly, a parabola would always be a parabola, and hyperbola would always be a hyperbola. Hmm. So it is actually a good confirmation because regarding the application of this kind of transformation. So we don't need to worry about the geometry. The geometric figure would remain the same, and just we shall apply this kind of transformation formula in order to convert them into their standard form. What is the standard form of an ellipse? Ellipse has the standard form that x square by a square plus y square by b square. This kind of expressions, x square by a square plus y square b square is equal to 1. This is actually actually the standard form of an ellipse. Similarly, the parabola can be written as y square is equal to 4ax. Hyperbola can be written as x square by a square minus y square b square is equal to 1. Circle can be written as x square plus y square is equal to a square. Hmm. So on and so forth. So all these different equations have different versions. For example, over here, parabola can be written as y square is equal to plus minus 4ax, or x square is equal to plus minus 4ay. Okay, so different forms might be there for parabola, hyperbola, ellipse, circle. But suppose you are given only this kind of equation, then how to conclude whether it represents any parabola, hyperbola, or ellipse, or any pair of straight line? And that is the process that we are going to discuss in this chapter. And that particular forms, as it has been presented over here, all these different kind of forms are actually called the normal forms or canonical forms of this parabola, sorry, of this kind of conics. Hmm. Now, what are the nature of all these kind of special canonical forms? Hmm? And mathematically, we are going to define this particular canonical form. What is this? It says about three different criteria, and in all these three criteria, the first criteria should be a compulsory criteria, and the second and third criteria is not a compulsion, but we try to apply this second and third criteria as much as possible, so that we ultimately convert them into a special kind of form that is actually called canonical form or normal form of the this general equation of second degree. Okay, so what is the first criteria? The first criteria says that this is the first criteria over here. This is the first criteria, that we need to remove the term containing xy. Okay, we need to always remove the term containing xy, and that is always possible. That is a very interesting part over here, that from a given equation of second degree, we will be always able to eliminate this kind of xy related term. I discussed earlier in the previous chapter that by rotation we can remove the second degree term. So over here we shall apply rotation, hmm, and we shall remove this second degree term, xy related term, and that is always possible, and this condition is a compulsory condition. Got it? There is a compulsion. So xy related term has to be removed. If you look at this, if you look at these forms, all these four different expressions does not have any term containing x into y. Okay, so that is always possible to remove the term containing x into y. So this is the first condition that is to be satisfied, compulsory. Hmm? And second criteria, that says that the number of terms in x and y, the terms in x, that means first degree term, and containing y, that is also a first degree term. Okay, the number of terms in x and y be reduced to minimum or completely removed. That means either if it is possible to remove all the terms containing x and y, for example, in case of ellipse, you would not find any term containing simply x, and similarly in case of hyperbola, you would not get any terms containing simply x. Similarly, you would not get any term containing simply y. Hmm. No first degree term is there in the equation of ellipse and in the equation of hyperbola. But a first degree term is there in case of parabola. There is a term 4ax. So in this case, the second condition says that the term containing x and y is to be made minimum. Okay, we have to reduce them to a minimum. That means either if it is possible to remove only y, we don't have any other option, we need to keep the term containing x. But our target would be to completely remove this term if possible, and if it is not possible, in that case we need to keep them in minimum. That means either we can keep the term containing only x, or we can keep the term containing only y. That is the second criteria. Okay, and the third criteria says that the constant term, this is the constant term. Okay, this is this c plus c, the constant term be removed if possible. Okay, over here it is not a compulsory part. If possible, we need to remove the constant term. For example, in the definition, in the equation of parabola, there is no more constant term, but in the equation of ellipse, in the equation of hyperbola, constant term is there. We cannot remove the constant term. Got it? Therefore, this is the third criteria that says that the constant term, either it is to be removed if possible. This is not a compulsory part. If possible, we can if it is possible, then we should try to remove that constant term, and if it is not possible, then we need to keep it. No option is there. So these three criteria, if certain equation satisfies these three criteria, then that particular form or that particular equation is called the canonical form or the normal form of that equation. Got it? Is it clear to you? ব্যাপারটা সবার কাছে পরিষ্কার হলো, কাকে আমরা canonical form and constant বা normal form বলছি?
Yes, sir.
Everybody clear?
Yes, sir.
Okay, thank you.
Yes, sir. Clear.
So that is the definition that can be asked in your exam as an objective question of 2 marks. Got it? So please try to remember this definition. And over here, the technique by which we are going to convert this equation, this kind of second degree equation, into canonical form or the standard form, that is actually done in order to identify whether it is an ellipse or parabola or hyperbola. That means we need to classify them into different categories. For example, classification in which character, in the character of eccentricity. We just say that if eccentricity is less than 1, then we obtain an ellipse. If it is equal to 1, then we obtain a parabola. If it is greater than 1, then we obtain a hyperbola. So this is a kind of classification depending upon the value of the ellipse. Sorry, depending upon the value of the eccentricity. Okay, and that particular kind of classification that is applied by the translation and rotation. And that particular kind of classification is called the metric classification of the conic. Got it? So that is a second definition that you need to know. What is this metric classification? Metric classification is actually done by the application of translation and rotation, and in metric classification we actually classify a general equation of second degree involving x and y into its different canonical forms. Got it? That is actually the metric classification of a general equation of second degree. And remember, this metric classification is also applicable in case of three-dimensional geometry. there is another same kind of equation, same kind of canonical form is there. Hmm. Over there in three-dimensional geometry, we will have three different coordinates: x, y, and z. And as per the truncated syllabus, they have just removed that portion, though it was very cumbersome job. Anyway, so as per this definition, you just need to remember that this definition is also applicable in case of three-dimensional geometry. Got it? In three-dimensional geometry as well, you will get this kind of classification, this kind of study. Hmm. Now, I am trying to show some results from this portion, because computation is there already. Hmm. Over here, what we are doing, I suppose there is any picture. No, no picture is there. So let me draw a picture for you. So these are the suppose two coordinates. Hmm. And I am first trying to apply a rotation uh, by an angle theta. Sorry. And suppose this angle is equal to theta. Okay, and this is our x prime axis, this is our y prime axis, and this is the, this is x axis, this is y axis, this is y axis. Okay, and the benefit of using this software is that if we just shift this page, this picture would remain be there. That's why I am trying to avoid this pencil or this kind of drawing tools, because in that case, if we draw anything out there, uh, and along with this page, it would shift up and down. Got it? Anyway, so let's continue over here. So this is the picture for rotation, and we are trying to apply this kind of rotation. That is the formula: x is equal to x prime cos of theta minus y prime sine of theta, and y is equal to x prime sine theta plus y prime cos theta. So we are trying to apply these two in the given equation. What is the given equation? This is the given equation. That is the given equation. And if we apply these expressions, that is a bit little cumbersome job. Anyway, so that is the expression of x over here, ax square plus twice h x y. This is the expression of y. And this is the expression of y plus twice gx. This is the expression of x, and this is the expression of y, and finally plus this constant term. So we get this kind of expressions. Now over here, you can expand it, you if you want. If you don't want, you can avoid to expand this line. So these are the expansions, and ultimately by computation we get this result. For example, in case of x square, this x square comes from this term, say x prime square, that is a into cos square theta. So this is the expression, a into cos square theta. Similarly, other terms would come from this kind of expressions. So we get this kind of result, that x prime in into this kind of expression cos of theta. Just it is a matter of manipulation. So may I skip this detailed computation? I am trying to skip this computation because it is actually a matter of some trigonometric computation. May I? আমি কি এটাকে বাদ দিতে পারি, নাকি করে দেখাতে হবে? তোমরা নিজেরা দেখে নিতে পারবে? হ্যালো, হ্যালো।
Yeah, sir. Yeah, sir.
তো should I skip this one?
Yeah, sir. You can skip it.
Okay, thank you. So আমি এটা বাদ দিচ্ছি, বাদ দিয়ে এই ডিটেল ক্যালকুলেশনটা আমি বাদ দিচ্ছি, বিকজ এই ডিটেল ক্যালকুলেশনটা আমার এই মোমেন্টে লাগবে না। হোপফুলি তোমরা নিজেরাও একবার দেখে নিতে পারবে, বাট প্লিজ গো থ্রু দিস computational step in your home. Okay, that would make you a bit comfortable, because the problem in at least in honors level, generally in 11 and 12, I don't know, did you face any kind of such problem or not? And that if you ask your seniors, you'd find that they were facing a problem. What is the problem? The problem is that in exam at least, hmm, you will get common questions, hmm, but when you start, ultimately in between the problem you get stuck, and you would not find any way out to overcome that problem. Sometimes you forget how to do all these steps, and that is mainly because of the fact that you lack the practice. Okay, so due to lack of practice, sometimes you get stuck in exam and you are not able to overcome from that problem. Hmm? Generally it happens to us everywhere, even to myself. I am studying this subject for more than 20 years, right from my graduation. Okay, so even with the teachers we also get stuck in between different steps. So just getting stuck in different step is not any issue at all, so don't shy about it. It is a normal thing, but what is the credit is that you just need to come out from that particular position. If you can come out from that particular position in your exam, then only you will become a successfully complete this course. Got it? And that is possible only by proper practice of all these manipulations. Hmm? So that is my advice, that you please practice all these manipulations in your home, because I am skipping for the sake of completion of this portion. But please don't skip yourself. Otherwise you will cheat yourself. তোমরা নিজেরাই নিজেদেরকে চিট করবে। এগুলোকে বাদ দিও না। এটাই আমি তোমাদেরকে রিকোয়েস্ট করবো। ওকে, so let's continue. uh, so ultimately, is anything else is there, because some sound is coming? Nothing. Hmm. Okay, so let's continue. Hmm. Over here, so we are applying some angle theta. Now, the first criteria in the this canonical form, that is the condition in canonical form. What was the first criteria? The first criteria says that the term containing x y is to be removed completely. Okay, that is a compulsory portion, and that is always possible. Why? How is it possible? If you consider this kind of expression x prime y prime, so if you want to remove the term containing x prime and y prime, that what you need to do, you need to assign this coefficient to equal to 0. So this expression twice h cos of twice theta minus a minus b sine of twice theta, this coefficient of xy has to be assigned equal to 0, has to be assigned the value equal to 0. Okay, so that is actually done over here. This is the assignment, that twice h cos theta minus a minus b sine twice theta is equal to 0, in order to vanish the term containing x prime and y prime. That was the objective. Okay, over here it is written that in order to vanish the term containing xy, you need to uh, vanish the coefficient of xy. And if we vanish this coefficient, then you will get this kind of term, tan of twice theta is equal to twice h by a minus b. And please try to remember this expression as a standard formula. Okay, tan of twice h is equal to twice h by a minus b. If we rotate the axis theta in such a manner that tan of twice h becomes is equal to twice h by a minus b, then you will always be able to remove the term containing xy. Okay, and then After removing the terms, ultimately the expression converts it into the form where you see x prime square is there, y prime square is there. The coefficient has been renamed as a prime and b prime. X prime y prime এর যে coefficient গুলো ছিল and the coefficients of x prime, this y prime, x prime square, y prime square, etc. This constant term, these are the new name of the প্রিভিয়াস এক্সপ্রেশনস। এই আগে যে এক্সপ্রেশন গুলো ছিল সেই এক্সপ্রেশন গুলোকে শর্টকাটে এরকম ভাবে নতুন করে নাম দেওয়া হয়েছে। দ্যাট ইজ আ নিউ কাইন্ড অফ নোমেনক্লেচার, দ্যাটস অল। হুম। সো আলটিমেটলি this equation number 2, after removing this x prime y prime related term, this the equation number 2 ultimately can be written as this kind of expression. Okay, now we are trying to further apply the other conditions, the second and third criteria. We applied the first criteria, we applied this criteria number 1, and successfully removed the xy related term or x prime y prime related term. Now we are trying to apply this second condition that says that we need to minimize the terms containing x and y, and if it is possible to completely remove them, we need to remove them properly. Okay, so over here, in order to convert this equation number 4, we are further applying is anything, some sound is coming. We are, who is this? Rahul, you are joining from the other accounts. Maybe it is not the account from created by your college. Please try to join the G Suite account. Hmm? You are not joining through G Suite account. Okay. Anyway, so let's continue. So over here, what we are doing over here, we shall apply the translation formula. What kind of translation formula? That is to be determined by this further computation. What to do? Over here, you see, this is a second degree equation. So this a prime, the coefficient of x square, and this b prime, if both of these two expressions become equal to 0 simultaneously, একসাথে যদি 0 হয়ে যায়, if both of these two both of these two coefficients become is equal to 0 simultaneously, then this kind of term would be vanished, and ultimately it would be converted to a first degree equation. So that is never possible, because a second degree equation can never be converted into first degree equation, whatever be the transformation, because the first degree equation always represents a straight line. We know, আমরা সবসময় জানি এই টাইপের একটা ইকুয়েশন সবসময় একটা স্ট্রেট লাইনকে রিপ্রেজেন্ট করে। হুম। So we know that the curve we are going to study is not always a straight line. Therefore we can say that this both of these two coefficients a prime and b prime can never be simultaneously equal to 0. একসাথে 0 হতে পারে না। Okay, simultaneously a prime and b prime can never be equal to 0. If a prime is equal to 0, then b prime should not be equal to 0. If a prime if b prime becomes is equal to 0, then a prime should not be equal to 0. Otherwise both of them are not equal to 0, but both of them can never be equal to 0 simultaneously. Okay, so three cases may arise. The first case is that this one over here, a prime and b prime both are not equal to 0. If both are not equal to 0, then you see this equation number 4, this equation can be written in this way. Over here, what we are doing, just try to understand. Over here, this a prime x square is taken, this twice g x prime is taken. And some extra term is added in this equation, g prime square by a prime. So that what happens, I am trying to explain it in this way. You see, I am trying to explain it in a file. We already do I have any ready-made file? Let me check. If I have any ready-made file, then it would be easier for me. No, I don't have any ready-made file. So let's demonstrate over here. A Let me identify this one. A x prime square plus twice, not twice, plus b prime y prime square. So over here, some a prime should be there. Hmm. Plus twice gx and g prime x prime plus twice a prime y prime plus c prime is equal to 0. That is actually the expression. Now what we are trying to do, let us write them again. I'm just making copy and paste. Now what we are trying to do, just over here, keep it this one and keep it these two, and now I am trying to make a perfect square expression out of this. How to make such perfect square expression? I am trying to first,
Sir,
yeah,
again I have an issue in that equation. Can you show me that again?
just a minute,
Yeah,
I
now
may.
it's perfect. Now it's perfect.
Is it so? Actually, this one.
Yeah, now
Okay,
it's
okay,
okay.
okay, okay. Thank you.
Yes, sir.
Now, what I am trying to express over here is that I am taking this small a common. So I would have g prime by a prime. Okay. So as because we have taken a prime not equal to 0, so this kind of manipulation is permissible in this case as at least. Now over here, this a prime divided by b prime. Now, in order to convert it into a perfect square, what we need to do? We need to write in g prime square by a prime square, g prime or whole square. Hmm. And over here, that is to be added and adjusted on the right hand side. But before that, let me write it. This one, a prime square by b prime square. Hmm. Now, what to adjust? You see, g prime square divided by a prime square along with multiplied by an a prime. Okay, so over there on the right hand side, what we need to do, we need to do g prime square divided by only a prime. Initially we had a prime square, but that a prime is multiplied by another a prime, so ultimately we have simply a prime. Got it? Similarly over here, plus a prime square divided by b prime. Okay, that is to be adjusted, and now we are keeping this c prime on the right hand side, so minus c prime would be there. So I am removing this one, so that would be the expression. Got it? Now now this expression, let me copy and paste. That is the benefit of writing everything in computer. Hmm. Anyway, so if we convert it into perfect square, it would be x prime plus g prime by a prime whole square. Hmm. So it would be x prime plus g prime by a prime and g prime by a prime whole square. Similarly, this expression would be y prime plus a prime by b prime whole square, and that is the expression. And now what we are trying to do is that we are now assuming that uh, capital X, maybe they have taken this capital X expression, I don't know. Let me check. Where is that file? This one. Maybe, yeah, they have taken capital X, this kind of expression. So let's take capital X over here. Let's take capital X. Capital X is equal to this expression. X prime to this, and and what would be capital Y? Let's take capital Y is equal to this expression only. Hmm. So if we consider it in this way, therefore we are now able to write this expression, this kind of second degree expression, in the fashion that this is actually our capital X, this is actually our capital Y, and let us consider this one as some other kind of constant, maybe say K or something else. They have taken this one as a K, this kind of quantity. Okay, so I am writing this expression, this right hand side is equal to K. K is equal to this. So I am taking again another one, say K is equal to this expression. Okay, some constant term is there. So that is actually the expression over here. A prime and B prime is not equal to 0. Now if you look at this expression, you see this can be written in this way. I am trying to write it in this way. A square, x square divided by A by A prime. It is a bit very small tiny quantity, x square by k by a prime, plus similarly over here y square divided by a, let me write it in this way, a by b prime, hmm, is equal to 1. So let me write it in this fashion, that a by a prime. Okay, so you see, if we now again consider the expression that k by a prime, if it is, I don't know whether k by a prime is positive or not. It may so happen that both of these two are positive. Okay, so if both of these two are positive, then we can consider this k by a prime is equal to, suppose, capital A square, and this k by b prime is equal to capital B square. In that case, we would be able to write this expression in this fashion, that this is equal to capital A square and this is equal to capital B square. So you see, this would be an equation of an ellipse. So what we are doing over here, we are actually, by this transformation, by this kind of transformation, x prime is equal to this, y prime is equal to this, but by this kind of transformation, what we are doing, initially we had x prime, this kind of x prime and y prime axis, and now what we are doing, we are actually making some translation, this kind of translation. I don't know whether it will be visible or not. Let me consider this line, this kind of translation. So now this is actually our x-axis and this would be our y-axis, this one. Okay, this would be our y-axis. So over here we are applying rotation and translation together, so that is actually kind of orthogonal transformation. Okay, and therefore under orthogonal transformation, this might become an ellipse. Now it may so happen that this is a positive quantity and this is a negative quantity. So if it is a negative quantity, then what we need to do, we need to write it as minus b square, so that we will have minus b square over here, and that minus can be written as x square by a square minus y square by b square is equal to 1. So that is again another kind of conic, that is called actually hyperbola. Hmm. Even this may be possible that this is negative and this is positive. So in that case, we would write this kind of expression, that minus x square by a square plus y square by b square. That is also a kind of hyperbola, that is called the conjugate category of hyperbola. Hmm. Now the question is that, is it possible that both of them are negative? Answer is no. Hmm. Both of
Equation
them,
factor.
cannot be negative, because geometrically, even if theoretically you get some negative values, but geometrically it does not have any meaning at all, because if it is a negative quantity, you see x square, like this kind of expression, If both of them are negative, then this expression is a positive quantity, this is a positive quantity, so altogether the left hand side becomes a negative quantity, and negative quantity cannot be equal to plus 1. Okay, so even if you get any kind of expression, I suppose you would not get this kind of result, that you ultimately get both of them negative. But even if you get this kind of result, then it does not satisfy any geometric curve at all. Okay, so that would be an imaginary curve. Even if you get this kind of result, we call it an imaginary curve, because I don't know currently whether after 100 year or 200 year would we get any proper explanation of this kind of imaginary curve at all, because the development of imaginary numbers took about 300 years to get a geometric interpretation. Hmm. So the geometric number root over of -1, okay, that took about 300 years to get its geometric interpretation. So we just keep all these idea open. If we get this kind of this kind of negative quantities, then we say that it is not a real curve. It might be some imaginary curve that we don't know. Okay, so that is a possible issue where a prime, if a prime is not equal to 0 and b prime not equal to 0, in that case you will be ultimately able to convert this equation in this kind of form. So ultimately you will either get get an ellipse, otherwise a hyperbola. Now is this much clear? এটা কি clear তোমাদের কাছে?
Yes, sir. Yes, sir. Sir, one question.
Yeah.
Sir, then this
Yes,
equation
sir.
will never satisfy a parabola, right?
I am coming to the definition of parabola. Okay,
Oh, okay,
I'm
okay.
coming to the case of parabola, but before that, let me tell you one thing, that if by chance this constant k becomes is equal to 0, I did not ever consider that k is equal to 0, because over there I divided the expression by k. Okay, so if k is not equal to 0, then only this kind of discussion is possible. But if k is equal to 0, in that case what to do? If k is equal to 0, we can show that it represents a pair of straight line, and that we shall discuss in detail in the chapter of pair of straight line. Okay, so I am keeping this open for discussion in the subsequent lectures. Got it? Next, if further k is not sorry, if the second case, what was the case? That was, the first case was a prime not equal to 0 and b prime not equal to 0. So in this case, either we get a parabola or a hyperbola. Hmm. And if both of them are negative, we call it an imaginary quantity. Somebody calls it a imaginary ellipse. So I am not currently discussing all these imaginary numbers. Now, now what we are doing over here, we are assuming that at least one of them, either a prime or b prime, becomes is equal to 0. Suppose a prime becomes is equal to 0. In this case, we are considering the fact that a prime is equal to 0. So I am showing the calculation from this expression. If a prime is equal to 0, then what we can do? I am just removing all these results, or we can just copy paste and show it afterwards. So the second case, over there, suppose if a prime is equal to 0, then this term would not come over here. I am removing this term. So our target would be to construct, okay, our target would be to construct this kind of expression. You see, over there, we shall keep this x related term separate, x prime related term separate, and we shall try to convert this kind of expression, as because b prime is not equal to 0, a prime is equal to 0 and b prime not equal to 0. So our target is to convert it into a perfect square. So we would make this kind of manipulation, and out there we delete this expression, and then we can delete this term as well. So this would be the adjustment for the term with this y prime, and suppose this expression is now transposed into the right hand side. Got it? So we will have this kind of expression, and what we shall do, Now we shall try to take the transformation. Over there you see this expression can be written in this way. This expression, this entire expression can be written in this way. We can take this twice g prime common. Okay, we can take this twice g prime common. In that case we would have twice g prime over here, and similarly we would have twice g prime over here. Hmm? So now we already have the expression, and again what we are trying to do, we are trying to convert this expression into perfect square so that it would be b prime into this expression, its whole square, and that is equal to this right hand side. Hmm. So that would be the expression. Now I am taking this capital X is equal to this expression. So you don't need to remember all this. You see, if this kind of reduction comes in exam, you don't need to remember what is X and what is Y. It automatically comes, the previous calculation would advise you what to take. So that I am taking this one as X, capital X, and suppose Y is equal to, say, this expression. Hmm. So that is the expression of y. So in that case this equation would be converted into this kind of expression, that this would be simply our capital Y, this would be our capital X, and therefore this expression can be written as y prime square is equal to minus twice g prime divided by b prime into capital X. Got it? And now if we can write them in this way, say for a x, where where capital A is equal to, what would be capital A with this negative sign, this much would be is equal to our capital A. So this is in the form of y square is equal to 4ax. Now it depends whether this is positive or negative. If suppose this is a negative quantity, then along with this negative sign, this a would be a positive quantity. But further, if it is positive quantity, then a should be taken in such a way that a it would always remain a positive quantity. So if it is positive quantity, then we can remove it and we can write it in this way. Got it? So in different cases, whether this is positive or negative, we would ultimately be able to convert this expression y square is equal to minus 4x or plus 4x, according as this is positive or negative. Hmm? Now, if this expression y square is equal to plus or minus 4ax, this would be the expression of a parabola. So ultimately, what we are doing, we are again applying some kind of translation. This is the translation formula. So ultimately, this kind of some geometric transformation is there, and ultimately, after applying this kind of transformation, we are now able to convert the given equation into the equation of a parabola. That is the case you are asking about. Hmm? So over here we will get parabola, and if suppose over here we have taken a prime is equal to 0, that's why we got this kind of parabola, y square is equal to plus or minus 4x. If b prime is equal to 0, then we would have different kind of expression. That means x prime would be plus or minus 4a y. That would also be a parabola. So in any case, okay, in any case, we can now conclude that the general equation second degree that we started with this expression. Where is that expression? This one. We started with this kind of expression. Okay, and we can now say that yes, a general equation of second degree either represents an ellipse or a parabola or a hyperbola, or it may represent a pair of straight line. So that is the discussion today I wanted to show you. about it, that we can now conclude this one, that hence in all cases a general equation of second degree represents a conic. In general, this parabola, hyperbola, and all this can be termed as conic only. Okay. Now, in the next class, I would discuss the nature of the conic. I would mainly try to discuss them in brief, because many computations are shown over here. We don't need all these computations. We need this summary. Okay. So in the next day, I would go through all this summary and this table in order to remember how to conclude, etc. And then probably after one more lecture, I would shift to the chapter general equation of the chapter pair of straight lines, because in order to complete the this chapter, you first need to go through the chapter of pair of straight lines. Okay. So this much I need to I wanted to discuss today. And if you have currently any query about it, you can ask. You can free to ask.
So not about the class, but one thing I want to ask, that
Yeah.
what is our syllabus for the first semester from geometry?
What? Sil-
What is the syllabus for the first semester in
uh,
geometry?
I discussed over here now the syllabus. I completed this one. This is the geometry portion.
Nah, the total chapters. What type topics are there? These unit three only.
Yeah. As per the geometry is concerned,
Okay.
in your so far in your first semester, this much is there about geometry. But this is not
Okay.
very small quantity. It looks that very small. This is a very large unit. Hmm. Though in brief they are written all these, because you see this general equation of second degree actually covers many chapters. If you if you want to study for yourself at least, this equation of second degree actually covers all these chapters in your book. The chapter 4, tangent normal, pole polars, diameters, all these three chapters they cover. Hmm. So ultimately, initially in your syllabus, all these chapters were there separately, and in detail study was there, and that was for myself at least, that was very good mode of discussion. But currently the syllabus is made in such a manner that just you
Someone
need
hearing,
to.
sir?
Yeah.
Oh yeah, yeah. So your video is stucking every time.
Okay, maybe some network issue is there. And I was telling that previously we had all these chapters, tangent normal, poles and polars and diameters. But currently, as per the syllabus I need to follow, the general equation of second degree is there. And only through this chapter I need to discuss all these tangent normal, pole polars, diameters, etc. And only the separately the polar equation has to be discussed. Hmm. So just I can
Okay,
say
okay.
the chapter 1 is there, transformation of coordinates. As per your book, the chapter 1 is there in your syllabus. Chapter 2 is there, pair of straight line. And then afterwards, I need to jump to the chapter number 10, general equation of second degree. I am talking about the book of Ghosh and Chakraborty. Okay. And then chapter number 11, the polar equation is there. But in between that, there were other chapters, tangent normals, chapter number 5, then poles and polars, diameters. All these chapters were there, but we just need to cover them only through this general equation of second degree. Okay, that's that much I can say currently. And any other question?
No, sir.
Okay, in that case, I should I now conclude. I am stopping the recording.